your destiny. Good morning, student. Good morning to your destiny. Now, like I've been showing you about the drawing. So this is the cam. This is the cam assembly, and this is the cam shaft, and this is the gear. This cam is driven by the engine like this. So as it is moving, you can see the follower here from this place. You can see the follower is also moving. So when you are told to draw the cam profile, you're simply going to draw how the cam is rotating the follower like this, because the follower has to be on this part. So when it is like this, the follower is lifted up. When it is like this, the follower is on dwell. When it is like this, the follower is still on dwell. When it is like this, the follower now has a return stroke. So we have the out stroke on the right, we have the dwell, then we have the return stroke, then we have the dwell, then we have the out stroke. Please subscribe to my YouTube channel and I will show you more about this. Now I want to show you now the displacement diagram. I have shown you from the previous video how all these things actually work. I have told you you must have a displacement diagram for you now to construct this cam profile that you have been told, because the section B, which has many marks, which has a lot of marks, which is 14 marks, than the first part of the question, which is part A. Part B is only telling us to draw cam profile and cam displacement graph. Now I want to show you how to draw this graph, cam displacement graph, because you cannot draw the cam profile without the cam displacement graph. So that's what I want us to look at. Now please subscribe to my YouTube channel. Now displacement diagram, and this is another subtopic. And here under this subtopic we have simple harmonic. We have 3 or 4 displacement diagrams. We have simple harmonic, uniform acceleration and retardation, and we also have uniform velocity, and all of them combined, the 3 of them combined. So under simple harmonic, there is a procedure that we follow, and I've written very well nice notes for you so that you can see. The displacement diagram is drawn as follows. The displacement under simple harmonic, remember the question will specify. Like for example here, when we are drawing in this question, we are told to draw the cam profile and cam displacement. Under this question, we are given the knife rotation, anti-clockwise rotation. We also given minimum and cam radius. They are given the cam radius. We have been given displacement, which is 15, which is also equals to stroke. Given the dwell, you have been given the rise of the simple harmonic, dwell, fall again, and uniform retardation, and the uniform acceleration and retardation with UAARM. Here we are using combined. Combined. The cam displacement will be combined. Will not be for simple harmonic. Will be for simple harmonic and uniform retardation, as we have been seeing, uniform acceleration and retardation. So you must also know how to construct displacement diagram under simple harmonic separately first, and also know how to construct displacement diagram under uniform acceleration and retardation. You must also know how to perform, how to draw displacement diagram, a displacement diagram under uniform velocity separately, so that you can now know how to draw when all of them are combined. That is why I am taking so much time so that you can understand. But quickly, let us first look at now the first one, which is simple harmonic. I will show you how to draw the displacement diagram of simple harmonic, and I've given you the procedure. The procedure is that the displacement diagram is drawn as follows. Draw a simple circle on the follower. Stroke as diameter. The stroke as diameter, I have underlined it. Please keep note of that. Number 2, divide the semicircle into any number of even parts. Divide the semicircle into any number of even parts. Then number 3 procedure you do is divide the angular displacement of the cam during outstroke and return stroke into the same number of equal parts. Then the number 4 is that the displacement diagram is obtained by projecting the points. Now I want to show you quickly how to draw. I'll just use random descriptions. I'll just use something. I'll just use any measurements or any measurements. First, to show you how to sketch them and how to draw them, because you need to know how to draw so that now you can actually put this into action. So let us assume that the stroke, remember the procedure number 1, you're told draw a semicircle on the follower and the stroke as diameter. The very first thing that you do here, you say, maybe let us say the stroke is let us say 6 let it be 6, let the stroke be 6 centimeters, like that. And it is like that. Then we also have this axis. We have this axis which we can, maybe you can call it the y-axis and the x-axis. The x-axis, let us give it how many centimeters? Let us just maybe we can give it 18 centimeters, like this, because we have to divide this into equal number. We must follow the procedure like that. 18 centimeters, like that. Also here, let us draw the 18 centimeters perfectly well, like this. Let this one be 18 centimeters, like that. As you can see very well, that is 18 centimeters, as you can see very well. So they are saying the first, draw a semicircle on the follower stroke as diameter. The stroke, I've told you, it is the distance from here to here. This distance, this is what we call stroke. And most questions you'll be given you'll be given stroke. You'll be given what stroke is. Now in our case, we have taken it to be 6 centimeters. So we are told to draw a semicircle. So a semicircle, we must take the radius. The radius will be 3. Take your radius as 3 centimeters, like that. Then maybe from this point here, identify your 3 centimeter. This is the 3 centimeter. Then from this point here, draw the semicircle which they are saying, like that. Draw a semicircle like that. You can see that is a semicircle. That is a semicircle that I'm talking about. Then what are they saying? The procedure number 2, divide the semicircle into any number of even parts. Let us now divide this into any even parts. First, from this point, you use construction line from the center where you've identified it. Use a construction line and project a line like that. A projection line. Use projection line like that and project a line like that. Then, if you don't know how to divide a semicircle into any equal parts, I will show you. The very first thing that you use, after you have taken this radius, using the same measurement of the radius, stand first on the middle part. Which is the part I'm talking about. This is the part that I'm talking about. This part is the one that I'm talking about. Like you can see in this particular instance, sorry, the camera is blinking, but it's okay. So from this particular here, this point is what I'm talking about. Here where they intersect, here where this line intersects with the semicircle, it is at this point here, as you can see here. Then make a mark like that on the top. Then on the bottom part with the same measure. So you come with your ruler again, stand from this point, stand at this point again, from this point, very well, correctly. So look for 4.5 centimeters, it will be at this point, that point. Then procedure, we have divided the angular displacement of the cam during out stroke, return stroke, and the same number equal parts. We have done it very well using a suitable scale. So the next thing is that the displacement diagram is obtained by projecting the points. So how do you project the points? Now this semicircle that I showed you here, you can see the semicircle that I showed you here. This semicircle that I showed you here and that we divided, these are the points you're supposed to project from end to end. So you stand here, you put your ruler parallel like this, parallel to this line, then project your line like that. Again, the next point, this is the next point. From this point, draw a very straight line like this, projecting to the other end. Then stand here, project another line from this point. You can see here I am projecting again another point like that. Then stand on this other point like this. From this point, yes, from this point again project a line like that. You can see very well like that using projection lines. Then we are told that we should divide outstroke, this outstroke, into the same number. Procedure number 3, divide it into equal parts. This part. Before we go to project number 4, we have to go to number 3, that we should we should actually do these things. We should actually put them, divide them into equal number. So dividing it is very simple. You come and measure with your ruler. Our ruler, we measure our outstroke. Our outstroke was how many centimeters? 4.5. So using again your ruler, using again 4.5, divide it again into equal number. You usually divide it into the numbers that you have used to divide this semicircle. That is the number you use. Here we use 6 points. 0, 1, 2, 3, 4, 5, 6. We used 6 points. So here you'll also divide this. Keep the 12. Going to the next point, take your ruler again, stand on this point, measure it. It is 3 centimeters. 3 centimeters, it is 3 centimeters again. 3 centimeters from this point, 3 centimeters divided by 6, it will be 0.5. like that. So that is a calm displacement and a simple harmonic. The next video I will now show you how to draw the uniform acceleration